everyone, myself Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science in the Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about what should be the concepts of sets here. So, it should be comes under the concepts of principles of data science. So, what is the set actually? So, set is nothing but well-defined collection of objects or distinct objects, and these set the objects in the set called as elements or maybe called as members of the set. And the capital letters like ABC are usually used to denote the sets, and the lowercase letters like ABC is going to be denote the elements of the set. Okay, so set is nothing but a set well-defined collection of distinct objects. Okay, and the objects in the set what we call as elements or members of the set. So normally we can able to use the capital letters for representing the set, when the lowercase letters ABC is going to denote the elements of the set. Suppose the collection of vowels in the word probability. So the collection of real numbers that can able to satisfy the equation, and the collection of two-digit positive integers. So that is going to be divisible by 5, and the collection of great football players in the National Football League, and the collection of intelligent members of United States Congress. So these are some of the examples of creating the set. So if I'm going to consider this, the collection of vowels in the word probability. So vowels means what we called as A-E-I-O-U, right? So for this word, what should be the set? Let it be B. So the set may be represented in flower brackets. So what is the letter is there? A is there, and A is not there, and I, O, that's it, right? So these are the elements of the set from the word probability of vowel set. Now similarly, so if I'm going to consider this equation, so how can able what numbers is going to satisfy this equation? Can we create a set like this? Like, what is the set I'm using here? So in this set, so what are the real number that is going to satisfy? Suppose if I substitute 2 square minus 9, 4 minus 9, that should not be equal to 0. And suppose if I'm going to consider 3 square minus 9 equal to 0, that is 9 minus 9 equal to 0. So this is the only value that can able to satisfy this equation. So the set is 3 here, and the collection of two-digit positive integers that should be divisible by 5. So what I'm creating a set, so the two-digit number which is going to be divisible by 5 would be 10 and 15, 20, 25, 30, 35, 40, like this. So these are all the two-digit numbers where it should be able to satisfy this. And the collection of football players also a set I can able to create. And collection of integer numbers of United States Congress can also be create a set like this. So next we are going to see what should be the empty set. So set is nothing but, so the set with no elements will be considered as an empty set, and also called as a null set here. So it is going to be denoted by symbol I, right? Null symbol, this one. The set of real numbers that satisfy the equation, this also be considered as a set. So if I consider this equation, nothing can able to classify here. So the set is not contain any kind of elements in the set. So this is also considered as a empty set here. Okay, the set with no elements considered as the empty set and also called as a null set here, which is going to be denoted by the symbol I, which is nothing but so the no elements are present in the set. And set of real numbers that can satisfy the equation is this. And next one is that so finite and infinite sets. So what is the finite set one? Which can be a counted one. So the finite means we can able to count the number of elements in the set. So that should be the finite set. So let it be. So example is that the set of two-digit positive integers have 90 elements. And infinite set is the one which cannot be counted here. That should be infinity is going on. And finite set, it should be countable. So the set of integers multiplies of number 5. So this one should be the infinite set where I can able to get it right. So the finite set is one which can be counted, and infinite set is the one which cannot be counted. So example, for the finite set, the set of two-digit positive integers have 90 elements. The set of integers multiplies the number 5. So what should be the cardinality of a set? So cardinality means it should be represent the number of elements in the sets. So the notation is that n of a. Suppose a set is going to be have this one. So what should be the cardinality of the set? Should be 5. So the number of elements that are present in the set should be represented as cardinality. So for finite sets, so n of a is the number of elements of the set. Okay. For the infinite sets, the n of a should be infinity here. Okay. So the cardinality value for the infinite set should be infinity, and finite sets it should be the number of elements of the set. So specifying a set here. So specifying a set means so here you can able to list the elements explicitly. So example like C is equal to A O I, and the list of elements implicitly what we called as 10, 20, 15, 20, 25 and 95. Okay, so the elements which is going to be represented explicitly called as I can able to represent like this. Suppose the elements can be represented implicitly can be written as like this. So we can also make the representation of the set. So by using a set builder notation, what we call how can able to write it here is that so q is equal to x. So x equal to p by q, where p and q are the integers and q is not equal to 0. So this one we called as a set builder notation. Okay, so specifying the set. Done in two ways. So one is through explicitly and other is through implicitly. And the notation will be called as set builder notation here. So x is equal to xp by q, where p and q are the integers, but q should not be 0. And next one is the universal set. So the set includes all the elements under consideration in a particular discussion. So depend on the context here. So example, the set of Latin letters, so set of natural numbers and set of points on the line. So universal set means that so the set U should be treated as a universal set that includes all the elements under consideration of particular discussion, and should also depends on the context. So examples is that so set of Latin names or a set of natural numbers and the set of points in a line like this. So what should be the membership relation? So the membership relation is that, so let A be the set and X be the sum object. So how can we able to represent the membership relation? So that means, so the element X at that, so that should be belongs to set A. How it means? So X is a member of X, or X is an element of A, or X belongs to A. So that should be negated by writing like this. So X does not belongs to A otherwise. Okay. So the membership relation, so of notation should be X belongs to A. What can able to pronounce it is that X belongs to A, or X is a member of A, or X is an element of A. So negated, so that should be does not belongs to A otherwise. So this should be the membership relation. And next one is equality of sets. So here I'm considering two sets A and B, denoted A equal to B if they have the same elements, otherwise A not equal to B. Okay, so the set A containing positive integers is not equal to the set of prime numbers. Similarly, the set of odd integers between 4 and 8, uh, the set of prime numbers between 4 and 8. So equality of sets. So let's take this. So set of integers between 4 and 8. So odd integers. So odd set I'm taking some like odd numbers like 5, 7. And similarly the set of prime numbers for this one is 5 and 7. So the both sets are said to be equal. Since the elements in set both are same. Okay, the two sets are said to be equal, denoted that A equal to B. So if they have the same elements, so if the number of elements are not same, then I can able to write it as A not equal to B. So subsets. So sub A is nothing but a subset of B if every element of A is an element of B here. That means I'm taking one set, right? So A equal to 1, 2, 3. B is equal to 1. So how can I say that the A is subset of B? That means the elements what are present in set A is also present in set B. So A is the subset of B. So how can I able to write A equals subset of B? And for each set, so A is automatically subset of A, and for each set, so the phi also belongs to set subset of B. So I can able to say that A is the superset of B if and only if A belongs subset of B. Okay, so for every set there should be an element. So notation means, so how can you write A is subset of B? So if all the elements are present, then it should be subset. For every null set should also be subset, and A is a proper set if and only if A should be a subset of B. So what kind of operations I can able to apply on sets? Like it be sets operations. For this set operations, I can able to perform union, intersection, like this. So these are some of the operations where can able to perform on set. So union, intersection, like so complement, like this. So what should be the union of two sets? So union of two sets, how can you able to write in set builder form? So A union B, X such that X belongs to A or X belongs to B. That means the element I can what is there in set A should also belongs to set B. Okay, so let's take an example. A is equal to 1, 2, 3, 4, 5. B is equal to 6, 7, 8, 9. So how can I able to write A union B? So X such that. So X belongs to A. What is the X belongs to A? 1, 2, 3, 4, 5. And or I can able to write that say X belongs to B also. 6, 7, 8, 9. So this should be the A union B operation. So that should be the union of two sets here. Here, what we call it as or here is inclusive operator. And next one is intersection. So intersection means uh, intersection of two sets will be represented as like this, and how this is write in circular form. So X such that. So X belongs to A and X belongs to B. That means so the X should be available in both set A and set B. So example, let A be the set of even positive integers and B the set of prime positive integers. So what should be that? A intersection B, so 2 only. So even positive integers maybe 2, 4, 6, 8, 10 like this. And set of prime numbers like 2, 3, 5, 7 like this. So if I apply what is the common element here? So 2 only. So intersection B is 2. So how can I able to say that the sets are disjoint here? So whenever the A intersection value does not contain anything, then it should be called as a pi here. Then it should be disjoint sets. So for intersection, suppose if I'm taking like this, so 1, 2, 3, 4, 5, and these the under set I'm taking. So 3, 5, 7, 8, 9. So if I'm going to write A intersection B means the elements which are common in A and B both. So 3 is there, and from 1 to 5. So both are common elements. So the A intersection B should be 3, 5. And next one is complement. So what should be the complements? So if A is a subset of universal set, the complement of A should be how can I able to write? So A complement means X belongs to universe such that so X does not belongs to A. So some of the equations will be A intersection A complement should be 9 and A union A complement should be universal set. Okay, so A is the subset of universal set, then complement of the set A is that is also a set here. So how can I able to write? So A complement means that so X belongs to union and X does not belongs to A. So A intersection A complement should be pi and A and union or complement should be universe. So how can able to represent these sets? What we have called as a Venn diagram. So what should be the Venn diagram? So the sets can be represented in the form of Venn diagram. So how it looks like? So can able to draw a rectangle. So within this should be called as a universal set, and A is the set, some portion of that universal set. So set A represent a disk which is to be inside a rectangle region representing a universal set. See, supposable Venn diagram of two sets. So this universal set is entirely different. So this set is containing 1, 2, 3, 4, 5, 6. So both are belongs to the universal set. If I consider this, so what would be? So 1, 2, 3, 4, 5. That means so the set is containing 1, 2, 3, 4 elements, and set B is containing 3, 4, 5, 6. So this should be the intersection part. That means these elements are present in both set A and set B. So if you look at like this, like 3, 4, 5, 6, 1, 2, 3, that means the set A elements should be 1, 2, 3, 4, 5, 6, and B should be 3, 4, 5, 6. That means the B should be a subset of B. That means some all the elements what are present in set B also present in set. So complement. So what should be the complement of the set? So that means if I consider this rectangle region, so the complement means the region that lies outside of it. That means the elements are not at all present in this region. Okay, so this should be the A complement. So no element is going to come into this region. So suppose the set is there. So all the elements rest of that should be the complement of set. So the shaded region is going to represent the complement of the set. Next, we will see that union of two sets. So union of two sets means so both the regions, all the elements what is present. So that should be the union of two sets. Okay. Suppose A is going to have 1, 2, 3, 4, and B is going to have 5, 6, 7, 8. So all the region is going to be shaded. So entire thing will be considered for the union of two sets. And next one is intersection. So intersection means some common part of the two sets. Just now I said, right? 1, 2, 3, 4, 5, 6, 7. So the common element between the two sets will be treated as an intersection of the two sets. So this should be the intersection of two sets. And so these are some of the various sets that is going to be formed by two sets like so R1 is equal to A intersection B complement, and R2 should be A intersection B, and R3 should be A intersection, and R4 should be this. So the two basic counting print rules what we are going to be follow for the sets should be A and B are the two finite sets. So the equation for N of A union B should be number of elements of set A plus number of elements of set B minus number of elements of A intersection B. Similarly, if I'm going to write N of A intersection B complement, so then N of A minus N of A intersection. Okay. Suppose if I'm going to give some values, right? So the number of I can able to construct this, right? So I'm going to have 1, 2, 3, 4, and B is equal to 5, 6, 7. So what should be the N of A here? 4. N of B here? 3. So how can I able to do? So I want to find. So A intersection B should be 0. So what should be N of A union B? So number of elements in set A plus number of elements in set B minus the intersection B. That should be 0. So what should be the N of A union B? Total 7 elements. So 4 plus 3 how much? 7. So like this I can able to find out this counting rules of cardinality of the set. Suppose from this equation I can able to find A intersection B. I can able to find so intersection B is equal to N of A union B minus N of A n of A union B equal to n of A plus n of B minus n of A union. So similarly, how can you able to find n of A here? So n of A is equal to n of A union B minus n of B plus n of A intersection. So from the equation itself, I can able to find the number of elements of set A, set B, and A union. Right.
Like, share and subscribe. Hit the bell icon for more updates.